Welcome. I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. With the help of my fantastic behind-the-scenes support staff of WBCC, we have developed a new series of lessons entitled Empowering Introductory Algebra. The series was created and has in mind students who have struggled with algebra in the past, and for you returning students who need a basic skills algebra review. Our wish is to provide you, the student, with the algebra fundamentals necessary to become successful upon entering college-level courses, even if you have never had any success in any mathematics course. So picking up where we left off in our last lesson, we were talking about rational expressions and reducing same fractions to 1 and reducing opposites to -1. So let's go to the graphic there and we will continue our adventure. And notice I've got here, therefore, to simplify rational expressions, factor all polynomials reducing any factors of 1 or -1. So let's go to some examples and look at that concept. So we've got 5x to the third over 15x, and we want to reduce this polynomial fraction. Now, the 5/15ths I don't think will bother anybody, but that'll be 1/3 if we want to go ahead and reduce the 5/15ths. And notice even the 15, when you were taught in grade school to reduce fractions, you could have turned the 15 into 3 times 5, and then when you canceled the 5s, anything divided by itself would have given you the 1 on top, 1/3. So that's another way you could look at reducing fractions. And remember power rule number 1, whenever we divide those same bases, do what to the powers on the x's? Subtract, and we end up with x squared in the top. So if we cancel an x out of the bottom and an x out of the top, we will be left with x squared. And when we look in most algebra textbooks, they won't put the 1 there. It's understood. They'll just write the answer as that reduced fraction x squared over 3. All right, so what you want to do is make sure you get factors and reduce. So look at this one here. A lot of students, when they go to cancel, they might try to cancel these x's out right away or chop them. They'll go, chop those x's, Young, and reduce that fraction. But oh no, don't go there. You can't cancel across addition and subtraction. We'll talk about that in a second. So Young, how do I reduce this polynomial fraction, this rational expression as you're calling it? Well, we're going to have to go back to our factoring from previous lessons and take out a what in the top in common? The greatest common factor. Always look for it first is 4, and then we're left with x minus 3. So what we have in the top and bottom now, notice we have x minus 3 with 4 in terms of multiplication divided by the x minus 3. So now we can go ahead and the x minus 3's or cancel them out, leaving me with 4. All right, for the answer. So you must have things in terms of multiplication, boy, and that is important. Let's go to the graphic here and look at that. Now, notice I've got a beware here. Do not cancel or chop across addition or subtraction signs because it doesn't make any sense. So notice the example I gave you there. 5 plus 1 divided by 5 plus 2, that doesn't reduce to 1/2, does it? If you go chopping the 5s, it doesn't make sense because if you added the tops, you would get 6 over 7 would be the correct answer. And it works for variables as well. Just because there's an x in the top and bottom of that second example, x minus 7 over x, notice in red there, do not put the answer -7. And if you plugged in numbers for x, it sure wouldn't come out to be -7, so it has to work that way. Let's go and show you some more examples here and show you why. So a lot of students, you know, they think that you can just cancel when you see something common in the top or bottom, but it only works if things are in terms of multiplication. So that does not reduce to 1/7 because that would be 5 plus 1 is 6 over 5 plus 7 is what there, 12. This wouldn't even come out close to 1/7, it'd be 1/2. But notice in the bottom, if you have 5 times 1 over 5 times 7, if we were to multiply that out, we would get 5 over 35, and certainly that does reduce. So once you get things in terms of multiplication, you can get out the black belt and go, and take those 5s right out of there. It does work. And that example we gave you earlier, do not try to cancel across that addition subtraction sign. You can't you can't cancel across the addition subtraction. If it's in terms of multiplication though, -7 times x over x, you can cross cancel the x's out to get the -7. So that is a huge point, and I see a lot of students make mistakes there. All right, so let's continue the reducing rational expressions. Notice I put factor and chop chop. All right, so can we chop the x squares here? Chop. No, that would hurt our hand. We go, and it would not chop across there. So you got subtraction and addition here. So what we have to do, I think some of you will recognize here, there's my friend, the difference of two perfect squares. And when we factor, we get xx plus minus what? 3, 3. So we get our conjugate friends back from factoring. So if you can factor, you can reduce these rational expressions real easy. And then we can do the old outside-inside thing on this. Factors of 6 that will give me 5 in the middle, I think we'll all see, is xx plus what? 2, 3. So now we've got things in terms of multiplication. We can cross cancel or chop. You can get out the Ginsu knives here or whatever and chop and say x plus 3 go out, and we're left with x minus 3 over x plus 2. All right, so that would be the reduced answer. Notice, don't try to cancel those x's, not across that sum and difference signs, only in terms of multiplication. All right, next example. We're going to factor these and cross-cancel anything in common. Now notice in the top and bottom here, there are some common things we can take out. In this top fraction, there is a common what? We can take a 2 out first, and when we take the 2 out, we're left with y squared plus 3y plus 2. And in the bottom, yes, something else in common there, so we're going to test your factoring here as well. You can take a 4 out, and what does that leave us? Y squared minus 3y minus 4. All right. Now, can we factor these trinomials? You betcha. Some of you recognize there are factors of 2 that will give me 3. There are factors of 4 that will give me the minus 3 with the signs, right? So we'll keep on factoring here. So we're going to go ahead and factor this top here into y plus. There's not a lot of choices here for 2, is there? 1, 2. And so those factors of give you the last 2 terms will also add to give you the middle up here. All over 4, and then we can factor this y squared minus 3y minus 4. So 1 times 4 is 4. Factors of 4 here, the signs would be different, would be y plus minus. This would be 4, 1. So now we can start chopping away here. We see some common things. So again, whenever you have the same thing divided by itself, it reduces to 1. All right, and even with 2/4, the fraction there, back in grade school, you could have written the 4 as 2 times 2 and canceled one of the 2's out, and that would have left you with the 1/2. All right, anything divided by itself is 1 in the top. So our final answer here, I'm going to have to bring it over here, I'm running out of paper, is y plus 2 in the top. Now the 1 we can just go ahead and throw out because 1 times anything's itself, over, don't forget this 2 down here though, because when we cross cancel the 2/4, we got 1/2. That 2's down there in the denominator times what's left when the smoke clears is y minus 4. All right, so this is the reduced fractional answer to that. All right, let's look at some more. I want to try to test you here and see if you remember something from the last lesson. Will this one reduce to 1, -1, or won't reduce? All right, well remember, what reduces this here? Well, are the signs the same in both variables? Both are negative x's, both are what kind of y's? Positive. Anytime you divide the same thing by itself, you get +1. Okay, so don't forget that. They'll try to trick you here. C minus D over D minus C reduces to, they are opposites, -1. Now you remember why they're opposites? The sign on the C's are opposite, the sign on the D's are opposites. You can plug numbers in for C and D and it will check. All right, now where am I going with this again? Let's go down here. We can factor a what out of the top here, so we're reducing these rational expressions today. You can take a 3 out, and that leaves you with a minus 5 over 5 minus a. So yes, I could cross cancel the a minus 5 and 5 minus a. So again, these are opposites, and when you reduce them, be careful. This reduces to a -1. So what we're left with is a -1 when we cancel these opposites times 3 for a final answer of -3. All right, so reducing rational expressions. Yeah.